Hi everyone, this is a short video to start off Chapter 7. And Chapter 7 is all about atmospheric circulations. We're going to go from very local microscale circulations to global circulations. They all follow a general pattern, and we're going to learn about what that pattern is. When we talk about the scales of atmospheric motion, as I said, we're going from microcirculations in a very localized environment out of a smokestack. That actually has a type of circulation that we'll refer to again and again and again, and it'll go all the way up to the regional level and regional weather maps, and then to the global level and transferring heat throughout the planet. We have vocabulary that we need to refer to in these different levels, so we're going to go over that a bit. They're talking about scaling this, and they change the prefix in front of it. From the local level is a microscale, then levels that are in an area, and that area could basically be maybe from a few acres to a few square miles. That's known as mesoscale, for middle scale, mesoscale. And then larger areas, big weather fronts across an entire region or across many states, could be in what's called macroscale, moving to entities that affect the entire globe, like jet streams that are on a global macro scale. So micro, meso, macro, we're going to cover them all. We're going to start at microscale and the eddies that we talked about in the smokestack. There is actually a lot of science behind smokestacks, and the eddies are the foundation of that science. It is talking about a whirl of air that forms on or as the result of an object that is in the way of the airflow. In this case, it is the smokestack that is containing the airflow out of an area or out of a building. That's considered an object that is impeding the flow and causing turbulence in the flow. And the whirls of air that form counter to the flow straight up, or the normal flow, are called eddies. And the size of those eddies and the number and the shape of those eddies are all related to the object that is obstructing the flow. When we talk about a smokestack, that's the object that is obstructing the flow. And when we talk about a mountain as obstructing the flow, that can change the shape and the size and the number of eddies. So in atmospheric science, we don't have smokestacks, we have mountains instead, and we have eddies or flows that run in circles counter to the flow of air over the mountain. Those are called mountain wave eddies. They can also have other shapes. There are mountain wave eddies, there are rotors, and there are turbulent eddies. All of them are similar in many ways. The way they impact you is they impact air travel, and they are the clear turbulence that you run into when the pilot tells you to put your seatbelt on. It's because it has been reported to him that there's turbulence in front of him. These are microscale issues. They're not going to show up on a weather report. They're reported by other pilots that are just in front of your pilot, and that are reporting back that they're running into it, and that you might run into it in a minute or two as well. In regard to the rotors that we talked about, these actually become clouds that are very dangerous for pilots, and you see the circular shape of the clouds and the way they are developing here, that circular shape rolling over, rotoring in. They can also take this shape when they form a complete circle. When pilots see these out in front of them, they avoid them by going preferably over them and climbing. And it's very difficult to see them at night, so that's where the pilots warn each other of what they've run into. To go into a bit of how eddies form, the obstructing object, which is the smokestack or the mountain, can cause wind shear. And to define wind shear a bit more for you, and we're going to get into this when we talk about tornadoes, wind shear impacts the vector of the wind. And we know the vector of the wind is the speed of the wind and the direction of the wind. Well, that obstruction can impact both. It can impact just the direction, and that would be directional shear, or just the speed of the shear. But most times, wind shear and the obstruction impact both the speed and the direction of the shear. And so you can imagine a jet that is flying through expecting a wind that is very predictable. If the wind changes in its direction and its speed, it's going to throw the plane up or down or change the plane's thrust through that speed. In this case, these rotor clouds, sometimes called billow clouds, the rotors are the full circle. The billows are the formation right before the circular action happens. So these are beautiful billow clouds that are right near the Appalachian Mountains. And rotor clouds might form near higher mountains where you can form the full circle, but these are right by the lower mountains, the Appalachians. They are very beautiful and very dangerous. What is forming them is noted here. So you are looking at an obstruction, the top of the Appalachian Mountains, which is causing a speed shear here. And this is below the top of the Appalachian Mountains, above the top of the Appalachian Mountains. That can increase as you go across a broad set of mountains. And then the peaks can cause directional changes here. You see the directional changes as well. Those speed and directional changes can lead to a circular motion, or at least a frontal motion that you're noticing there. So while they are very beautiful, they are very hazardous to aircraft. We'll meet you on the other side for more mesoscale circulations.